Greetings, my little triglets. Welcome back. We are going to do section 7.6 today. Section 7.6 has to do with rational functions. And rational functions, if you remember, the first 5 letters is ratio, and that has to do with fractions. A rational function might look something like this. Where you have it in the form of a fraction. Now, in this case, the only number that x cannot be is a -3, because that would make it have a 0 on the bottom. So this graph, if we're to graph it on the graphing calculator, is going to have an opening at the spot where x equals -3. Now let's reduce this by hand. That top part can reduce, to the equation x plus 3 and x minus 3, and the bottom is x plus 3. Now I can cancel these two just to get the equation that I'm going to graph. So what I'm going to do, slope is 1 over 1, go down to -3, and then go up 1 over 1. And there's your graph. Now, because I said x cannot be -3, when you draw the graph, let me get rid of this right now. When you draw the graph, you actually have a hole at when x is -3, right below it. You can't see it when you graph it on the graphing calculator. You just have to know it's there. If you zoom in a million times, then you might be able to see it, but you just have to figure it out ahead of time and know that there's going to be a hole in the graph there. Now we're going to have a few different types of graphs, different looking graphs. Let's look at the one that says y equals 1 over x minus 2. So 2 is where the dotted line is going to be our asymptote. Now if you graph this on the graphing calculator, which we will do tomorrow, you're going to see the graph looks something like this. Okay. And here, there's a dotted line that comes down. Come on now. Here we go. Where it's going to be the asymptote, and that's going to be at 2. So 1, 2, we'll say it's there. But there's also another one here. This, if I were to extend this graph, it would go down, 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 and it would get very close to the x-axis, but it would never touch it. Same way with this one. It gets very close, but it doesn't touch it. So we actually have two asymptotes. One is the x-axis, the other one is this dotted line. Now there's something that you're going to need to know in calculus, and we're just going to kind of dabble with it right now. And let me go to the next page, and we're going to redraw this because I need a little bit more room. So this goes in here, dotted line at 2, 1, 2, and then this one goes here. So what we're going to do is something called limit notation. Limit notation is a way to describe this graph without actually seeing it. So we are going to take this top arrow. Oh, come on now. Let's see, I want a different color actually, this top arrow. So that top arrow is the up arrow. And the way we do this is we say the limit of f of x, the limit of our function equals, now how far up does this arrow go? Well, it goes forever. So the limit of our function is infinity as x approaches, now you have to think x being the left and right. The limit of f of x, this part here is kind of like your y value. The y value is going up, 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 up forever. That's why it's to infinity. But the x value is like your left and right movement. So this thing is going to the left towards this dotted line, but it's never going to cross the dotted line. So we say that as x approaches 2, and it's coming from the right. So this little plus sign means from the right. If it's from the left, we would put a negative there. So that's how you would describe that top arrow. Now let's do the bottom arrow. We'll make that one green. This time our y value, or limit of f of x, is headed down forever. So down would be negative infinity. But the left and right movement of this green arrow is it's moving that way towards that 2 again, that line that's on the 2, and it's coming from the left this time. So we put the little minus sign after the 2. All right, let's keep moving here. Let's do the right arrow. Okay, always start with limit of f of x. So the y value is your up and down. It's actually moving down. So it's headed toward this x-axis, which we call, you can just call it 0. As x approaching now, is it moving left or right? Looks like it's moving right. And it's going to go forever, so we can say infinity. Okay, it's infinity there. All right, and then let's do the left arrow. Again, limit of f of x. The y value is going up, headed towards the x-axis, which is 0. The x value is moving left, which is headed toward negative infinity. Now you only put the plus and minus on the up and down arrow. You don't do them on the right and left because it's going to infinity, so it doesn't really need a description that way. But that's your basic limit notation. All right, the next thing you're going to have to do is find the x-intercepts. Okay, finding the x-intercepts, you can do it by hand. You can go to the solver button on the calculator, but it's not real reliable. I don't like to teach it using that, but you can do that. The description is in that sheet of paper I gave you. But let's say you have y equals 3x minus 5 over x minus 1. Algebraically, to find the x-intercepts, you put 0 in for y and then solve for x. So let's put a 0 in. 0 equals 3x minus 5 over x minus 1. Now you can cross multiply. X minus 1 times 0 is still 0. And then bring the 5 over and divide by 3. So x equals 5/3. Okay. To find the y-intercept, you put 0 in for x and solve for y. Whoops, solve for y. Let's see if you can read that. Let's try it again. Okay, so this time I'm going to say y equals 3 times 0 minus 5 over 0 minus 1. So y equals negative 5 over negative 1, which is 5. So that's the y-intercept. So if you graph this on the graphing calculator, you might see an equation like this or a graph like this, and then this would be the 5/3, and then actually I had needed to have that come over here. This would be the that's not working. I think this one would have to be up here, so this would be the y-intercept at 5. I'm just making this up as I go, so that's why it's not going to work out perfectly. So this would be the 5/3 here, and this would be the 5, if this were the picture of that equation. I don't know if it is for sure, but we'll just wing it. Okay, so those are the couple of main things I wanted you to know: limit notation, and then finding the x and y intercepts. The rest you'll be able to do on the calculator. We'll practice that tomorrow. Alrighty, ta-ta for now. Don't forget, Trig loves you. You must love it back.